So, hello everyone. I'm Kanchan Moite, working for EnterpriseDB. I am past 10 to 12 years. I am with EnterpriseDB working on databases, and that's what I love to do, and that's my passion. So today we are going to talk about the database deployments, basically Postgres deployments everywhere. I'm sure most of you are aware of Postgres, but if not, I'll just give a brief introduction there. The world loves Postgres. If you work with developers or data scientists or anyone wrangling data, or you are the one who does that, you've probably seen the sticker with the tusk and trunk of the Postgres elephant on the lid of the nearby laptops. EnterpriseDB has a lot to do with that. In today's presentation, followed by a demo, I'm going to focus on Postgres deployments using Terraform. So Postgres is the most advanced open source relational database system. With over 30 years of active development, Postgres has earned a strong reputation for reliability, for data integrity, for feature robustness and performance. So with improving the Postgres deployment experience by designing and developing automation that makes deployment in the cloud, on-prem, or in containers easy is what we are aiming for. Whether you are a new user trying to deploy Postgres, or you're an enterprise with Postgres experience, you can equally leverage the simplified deployment that we have to offer. This deployment takes care not only takes care of the database itself, but also we are talking about the enterprise class database management as a platform. I'll expand more when I say what Postgres platform I'm talking about. Before we get into that, Postgres is not about being locked in one platform. The future of Postgres is about platform independence. Partnering with customers and encouraging their growth with Postgres is what we strive for. Briefly talking about the agenda, it's going to be simple and straightforward. As I said, quickly, I've mentioned about Postgres. I'll talk a few minutes about EnterpriseDB and what we are into. Postgres platform that we are going to deploy and show you the demo about. We are going to talk about the Postgres platform and top 3 use cases that the database deployment, the enterprise deployments should be looking at. It should have built-in replication and high availability. It should be fault tolerant and resilient. And last but not the least, you have to manage Postgres at scale. We are not talking about a single database here. It's more about hundreds and thousands of database, how you manage those kind of at scale. So let's get started. Sorry. I'm sorry. Okay. So EnterpriseDB or EDB is leading global provider of Postgres, and we have 16 offices worldwide. We enhance Postgres and make it enterprise ready. EDB continues for the 7th consecutive year to be recognized amongst the elite database vendors in the Gartner quadrant, the Magic Quadrant for operational database management system. EDB now is the only open source relational database vendor in the Magic Quadrant. Our customers are investing in Postgres in all kinds of ways, and we are proud to call thousands of boundary pushing customers as our partners. Our customers use Postgres not just for the Oracle compatibility that we provide, but also for net new application development, analytics workload, or across various platforms, be it on-prem, cloud, containers, whichever they choose for. As a partner, we encourage their experiment and help them along. Partnering with customers and encouraging the growth with Postgres is our mission. Just like the HashiCorp community, Postgres is a big, vibrant, dedicated community, and the dedication of the open source Postgres community behind the software to consistently deliver a performant and innovative solution is commendable. ADB has been a major contributor to Postgres for last 15 years. Ever since 2006, ADB has contributed to Postgres and continues to do so even today. So these, all my colleagues at EnterpriseDB are actually Postgres contributors and committers as well. So coming back to our deployments, this, as you can see, is a list of database deployment targets across the world and in all types of organizations, of all types and sizes of organization. Postgres is deployed in all popular environments, as shown here. The deployment scripts that we are going to see in the demo, it's version 1, and we have developed it for public cloud AWS provider and for VMware vSphere. And we'll be adding the providers at a good speed based on user inputs. It's going to be on GitHub, and anybody can just start using it, download it, and get it running. So let's get started with the option to choose from the database. You can choose the plain vanilla Postgres, the open source version Postgres, or you can go ahead with ADB Postgres Advanced Server, which comes with added performance tools, enterprise security, Oracle compatibility, and productivity enhancement features for your developers or DBA. Basically, it's the same Postgres. The enterprise Postgres is the same Postgres as the vanilla one, with some additional capabilities as I just mentioned. The power of ADB Postgres comes from its technologies and capability that offer interoperability, flexibility, and greater control for someone of an enterprise class customers. Basically, that's what we have seen. About the Postgres platform, I mean, a Postgres database, if you have a use case where you're just connecting to a single database, that's good. But if we are talking about more of an larger deployment, or you're talking about an enterprise production class use case, obviously, Postgres platform rivals with traditional vendor offerings for feature and performance, yet as an open source based provider, offers dramatic cost savings and greater flexibility. The ADB Postgres platform, the database, it comes with all the tool sets that were born directly out of the requirements of the larger enterprise customers of ADB, and covers more use cases than the community tools can provide. So basically, it's one-stop shop for best of breeds capabilities. And also, it's complemented by a portfolio of support, training, certification, Postgres, professional services offerings, etc. Okay, coming on to the top 3 use cases that we wanted to focus on with the deployment scripts. For an enterprise class use case, basically the Postgres has to be highly available and resilient. When I say highly available and resilient Postgres, what does that include? So when I deploy the script, basically it's going to create a 3-node cluster for me, where 1 node would be master and 2 would be the replicas. The replication between master and the standbys or the replicas is set by default. As a user, you need to input the variables, whether you want synchronous replication, whether you want asynchronous replications, and it offers that flexibility to customize as per your use case needs. I'll be giving the demo for AWS. So when I say high availability, basically master and standby is going to be spread across. In AWS parlance, it's more of that the master and the various standbys are going to be on different availability zones. So if one of the AZs or availability zones goes down, we still have the Postgres cluster running and serving the application. So that's where the availability come in, and it can be across AZs, it can be across different regions. So the master can be in one region, whereas the standbys can be on different regions. So that is what I mean when I say highly available cluster, which would also have the load balancing capabilities. When I say load balancing, what do I mean here? So basically, as I described, the Postgres cluster is going to be one master and two standbys by default. You can always increase the size of the cluster or decrease the size of the cluster depending on your needs. So master is the application connection or the database connection. Master is going to get both the read-write connections, and the replicas are going to be read-only. So load balancing, high availability, replication. That's what we need for a highly available load balance Postgres. That's the use case one. Second use case, basically, we want the Postgres to be fault tolerant. I mean, we are talking about a production workload here. It should have the self-healing capability. It has to make sure that if there is any failure, the failure is detected and it's automatically there is a transfer of control from the standby. If the master goes down, the transfer of control happens from standby to master, and everything runs smoothly. The application is not even aware that the database had any issues. So that's an important, that's a must-have capability. And in addition, there are features where you could avoid split brain scenarios. We will talk about it. And also switchover capabilities, where we want the nodes to switch their roles. So master can be switched as standby, and the standby could be switched as master. And we require such kind of switchovers for regular maintenance activity, upgrade, patching. So there are use cases, and I'm sure the DBAs are aware of all those things. So that's my second second use case in the top 3 list, where fault-tolerant Postgres cluster is important. And the third one, so as I said, we are talking about Postgres at scale here. We are not talking about a single database, a test use case which is connecting us to a single database. We are talking about hundreds and thousands of Postgres nodes. So there has to be some tool which would monitor and manage and tell you about the health. It's going to alert you for if anything is wrong. You need to have dashboards. Communication needs, the emails, SMTP, SNMP alerts should be coming in. So all those things. So manage and monitor Postgres at scale is the third one. I would want to spend some time on each of the use case that we talked about, so that everybody is clear when I say Postgres deployments, why is it available, and what is the enterprise platform, Postgres platform that we're talking about, which is easily made available with the Terraform scripts that I'm going to show it in the later part. So again, just to revisit, we saw in the previous slide the 3 use cases. The use case 1, which we saw, the Postgres built-in high availability. The architecture diagram would look more or less, it's going to look like the way you are seeing it on the screen. Cluster would be multi-node with one master and multiple standbys. As I said, by default, we are going to create a 3-node cluster, but it's up to the user. He can input and change the cluster size and increase the standbys based on his requirements. The ongoing data replication need to happen between the master and the standby nodes. The replication can be synchronous replication or asynchronous replication, or maybe a mix of both, based on the use case requirement, that 2 of my standbys are asynchronously replicated, and so 2 of my standbys can be synchronously replicated from the master, so all of them have the same data sets. And maybe one of my standby could be an asynchronous replica, which could be my disaster recovery site. So there are ways how I want my use case to be, and we are giving that option for the users to choose from. Having, as I said, load balancing. Having multiple nodes is going to help you with the load balancing, number of connections to the database. Master is going to take both the read-write request, and the standbys are going to be catering to the read-only request. And for high availability purpose, as I said, it's good, the master and standby across are going to be spread across. In AWS parlance, it's mostly across various availability zones, and in the same region, or it could be across multiple regions. So use case one, Postgres cluster, built-in high availability, load balancing, must-haves. Second one, fault-tolerant Postgres. When I say fault-tolerant Postgres, for the Postgres cluster, along with high availability, fault tolerance, self-healing nodes is the requirement to minimize the downtime here. So their Postgres Enterprise Manager, which is an EDB tool, is going to help you with that. It detects any compute, network, or database failure quickly to automatically promote the most recent standby and reconfigure other standbys to point to the new master. So this is all going to happen under the hoods. EDB, Postgres Failover Manager, or EFM would have agents, as you can see in the diagram. The EFM agents, which I've marked in orange, are going to run on the master and standby nodes, continuously monitoring the health of your database. And when the failure is detected, agents is going to send an alert. So email alerts would be sent, and it would initiate auto failover, or it would wait for the user to take appropriate action the way the user has configured it. Again, avoiding those who have worked with databases intensively are completely aware that avoiding split bear scenarios is very important here. You cannot have two masters by having wrong configuration sets. That can wreak havoc on your setup. So basically, this would help you avoid split-based scenarios, and also the time lost from triggering negative false or unnecessary failures. False negatives, it would never happen, and unnecessary failures won't take place. So, and that's going to help you minimize the downtime for your application, and it's also going to help you maintain the high availability that we talked about in the use case one. Quickly want to touch on the switchover capability, which I had mentioned earlier. EFM allows you to switch, allows any of the nodes to switch from standby to master or master to standby. And why this is necessary? Obviously for upgrade database, upgrade patching the database or the operating system with minimal downtime by switching the roles between the master and the standby. Third use case, when you want to monitor, as I said, Postgres at scale. That's where ADB's Postgres Enterprise Manager is to the rescue. It collects the performance and status data from the database, from the OS of the nodes and the jobs that are running on the database host using the PEM agent. So Postgres Enterprise Manager, PEM. So we can have the PEM server and the PEM agents. Agents are running on each of the nodes, and agents are going to send the data to the PEM server. So data is stored and aggregated with key metrics and is displayed at a glance on the dashboard. Alerts can be relayed via built-in or custom charts and dashboards, email or SNMP notifications, and also can be integrated with any other monitoring tools that your organizations may have. And so PEM not only helps you to just monitor or manage, it basically helps with tuning. It allows you to tune slow running queries. It helps you identify the resource bottlenecks, and also helps for the forecast future needs. So again, just to wrap up, 3 use cases that we saw: high availability, fault tolerance, and manage Postgres. Now I'm going to switch my screen and go to the demo part here. So I'll just, so these scripts are available on GitHub at EnterpriseDB. Once you clone the repository, this is the directory structure that you're going to see. So DB cluster, as I had mentioned earlier, we have developed VMware. We've used Terraform for provisioning the infrastructure across the multiple providers, currently two. At present, as it's clear from on my screen that the scripts are available for AWS and VMware, but at user request, we are going to enhance the providers quickly. So Terraform is going to act as an orchestrator. Terraform being an infrastructure provisioning tool, the infrastructure part is going to be taken care by Terraform. And basically, the database configuration part is handed over to Ansible, because because Terraform does not come with good with higher config management system. So that's where Ansible comes in. So we've used Terraform to stand up the virtual machines or cloud instances here, and then we hand over the reins to Ansible to finish up the configuration of our Postgres database, and also the tools that we talked about, Enterprise EFM, the failover manager, or PEM, the Postgres Enterprise Manager, for monitoring the Postgres needs. So let's dig in. Once you clone the repository, these are the directories that you're going to see. So DB cluster AWS is going to allow me to help the cluster. So basically, if you see here, I have just logged in into, so I have went into that directory. It's going to ask me to input the parameters, be it database user for AWS infrastructure, your secret access key, or if you want to use a specific role, it would allow you which region you want to take care, which region you want to deploy the cluster. It's going to ask you that value. And once if you want to customize the database user password, I'm sure, I mean, every use case has its own customized input requirements. So once you input or fill in that file, you just hit Terraform apply. I had already run this, kept it ready so that we don't, I was not sure whether the recording time is going to be sufficient. So I've already done a Terraform init where I've initialized it and input it. And I had hit the Terraform apply, which gave me the cluster up and running, the 3-node Postgres cluster, which is up and running and waiting on me. So coming back, here we are. So just a minute. Right here. So once it executes successfully, it's going to tell you that which database. I had chosen Enterprise Postgres version 12. The database version available are 10, Postgres and EPAS version 10, version 11, and version 12. So all 6 permutations are available to you. You can choose any of them. This is the AWS provider. So I mean, I can quickly show you the customized input file as well. So yeah, which these are the parameters. So these are the mandatory fields that the user is expected to put in, which instance type you want to create on your Amazon infrastructure, what is your key pair, which subnet you want to launch it in, which VPC you're going to basically, in which VPC, which subnet is going to be available for your cluster. And for the replication that we talked about between master and standby, what is there any replication password that you want to set? As I have filled in all the parameters, what each parameter is for, the details are right in the file. you can fill in the parameters and execute, and the cluster is up and running for me. So now I log in into master, and I will connect to the database. Insert some data. And I have it up and running. So I have my cluster up and running. If required, I can obviously go and check into my AWS account. Okay, so here I see that my master is this, and slave 1 and slave 2 are up and running. So that's good. No issues there. So moving on. For the management server that we talked about, again, it's pretty straightforward, where the PEM agents are on each of the nodes, whether it is master or the 2 standbys, and they would start sending the data to the PEM server. So this PEM server, the PEM server we got an IP was 126.140.102. So I will log in into the PEM server based on the user password I had chosen when I created. Okay, EnterpriseDB. So that's how the PEM server is going to look like. It's showing me that my 3 nodes are up and running, and it's going to show me that these are the agents which are running on the nodes that we had launched with the Terraform scripts, and the PEM server it's going to start collecting the data. So I can just go in any of the nodes and see what is going on. So this is the management or the monitoring tool that I was talking about, and you can see how important it is to have such kind of monitoring tools where you could set specific alerts, where you could do various dashboards, where you could set the management tasks, where you could manage or create your own alerts, set some thresholds, where the Postgres log analysis takes place, where tuning wizards is going to help you with the tuning parameter suggestions. And it's an enterprise class tool which is required here. So going to our failover case, again, inputting my properties in the EDB EFM cluster input file. I have put in what I want. I need to have the yum repository user ID password, which once you register at EDB, you're going to get it. My DB user is Postgres, and I want to make sure that the password is set there. The email notification is being set, where I could receive if the database goes down or if there is any problem that has been detected. I've asked it to send that in email on my personal email ID. So once I'm done set, I've already added that. I'll go and check. So here, as you can see, the cluster status shows me that the master is running, and the agent and the database both are up and running, where I can easily add the standby priority list. If the master goes down, we can set the priorities for each of the standbys, and once if the master goes down, the standby would be automatically promoted and take care and become the new master, and the remaining standby would configure with the new master, the way we had discussed on the slide deck. Other than that, one more functionality that we have added with the top cases was also about expanding the cluster if required. So we saw that DB cluster allows you to launch a cluster. EFM, failover manager setup, we saw here. If I check that, okay, what are the wall files which are received, if where is the data, whether the master and standby, this shows that my master and standby are in sync, and it's going to continue working and monitoring. PSQL, I will connect to the database, and for the streaming replication part, as we had seen earlier, we had created one table. So I'm going to insert some more data, insert into T1 values, generate series 1, comma. Oh, sorry, me and my fat fingers. Okay. So as you can see now, if I again do a cluster status, initially our WAR files was 604C7E0. Now with insertion of data, that has moved ahead, and still the master and standby are in sync, and that's what the failover manager is going to show you. It's going to monitor for any database failure, for any network failure on the cluster, or even the host failures that we can see. In addition, as I was trying to show, if we need to, so that's our EFM setup. There is an option, something which is called as expand cluster as well. So if you want to add one more replica, you decide that the load is growing on the database, and we need to add an extra replica to start load balancing it. So we can still go ahead and do that. I want the same. I've already input the input file, and I'll take it from there. I'll hit Terraform apply. I want it on the same region, and while it is working, while it is trying to get the extra data added, we'll see about the other features that I wanted to quickly show you guys. Sorry. Okay. So we talked about DB cluster, which creates a cluster. Failover manager is being set up here and configured via the Ansible playbooks, which are part of these scripts. Expand cluster, we have already started that operation. Agents we have configured on each of the nodes, and server has started collecting the data, which we saw with our PEM server right here. So that's all set. So coming back, whether we have completed, I'm sorry, I have too many tabs opened here. Okay, so while that is still going on, I'll go back to the presentation. Again, just to make sure that everybody takes away the key takeaway from my perspective is Postgres deployment made easy. I mean, most of you must be aware of how Terraform and Ansible works, or how Terraform is used as infrastructure as a service. So I have not focused my presentation more on that front. It's more like how Postgres database you can easily easily set it up, get it deployed like within minutes. It's very easy. And if your use case is just get up and running with Postgres, you can still use this test case. But then if you are more of an advanced user and want to try out an enterprise class kind of use case. These are the important points that you need to keep in mind, and this is what the Postgres platform is going to give you: built-in replication, high availability, fault tolerant and resilient Postgres, and managed Postgres at scale. Again, if you have any questions accessing the scripts from the Git repository at enterprisedb.com, please don't hesitate to mail me. My email ID is my first name dot last name kanchan.mohiti@enterprisedb.com. Again, I'll be happy to answer any of your questions, queries, or you can comment on the GitHub site itself, and we can take a look into it. Thank you, and that's what I wanted to cover: Postgres, EnterpriseDB, and how everything works on the deployments, how easy it can be using Terraforms. Thank you.